Welcome to the first in a new series of videos on the Scan AI channel that will look at the impacts that AI is having on a number of key industry sectors. And we'll start by looking at the field of robotics, where different applications of AI are being used in a wide variety of scenarios, including smart automation for manufacturing, last mile delivery and logistics, remote surgery and healthcare, and reducing human risk in the military. Now, the use of robotics in many of these industries isn't necessarily new. For example, the manufacturing sector has long used automation to carry out repetitive tasks on production lines. However, the advent of AI has introduced the ability for these robots to be trained using vast data sets to recognise and adapt to a variety of scenarios without human input. Sensors for vibration, temperature and humidity can be paired with cameras so that a robot can perceive its surroundings, the task that it's undertaking, and recognise any anomalies that may cause an issue. And this allows for a greater degree of automation, increases resiliency to changes and unexpected factors, and even leads to predictive maintenance capabilities that may prevent downtime before a problem actually occurs. For these examples, we're going to look at a number of projects being worked on by the Oxford Robotics Institute, or ORI. The ORI is an interdisciplinary division within the University of Oxford's Department of Engineering Science.
What we're all about here at the ORI is having machines answer three questions. Where am I? What's around me? And what should I do? And they answer those questions so we can have better machines that help us. We used to be around driverless cars and mobile robotics, but our mission's now expanded to all the things that move. So flying vehicles, walking, running vehicles, rolling vehicles, off-road vehicles, in the Arctic kind of vehicles.
In order for a robot to fully function completing any automated task, it must be able to recognise the object or objects that the task is concerned with. For example, in manufacturing, you might want to teach a robot how to perform new tasks with components it might have never seen before. And rather than trying to collect labelled data for every possible situation, it's possible to develop unsupervised methods that are able to identify object-like things in sensory data without labelled supervision. And this can be achieved by building knowledge about the world into a machine learning model. Facts such as objects are typically spatially localised. They persist over time without magically disappearing, and that two objects cannot occupy the same physical space. This knowledge can be used to build machine learning models that are able to discover objects like things without requiring any manual annotations. These principles were applied by the ORI team to enable the development of a novel object-centric generative model, which learns to segment objects into images without labelled supervision. The different coloured blocks in the images are identified as separate objects automatically by the robot, thus enhancing its ability to learn faster when presented with new and previously unseen components or parts. Our next project looks at an application such as using robotics for military purposes. An automated logistics robot would need to have certain resilient characteristics to ensure it could cope with external factors, such as adverse weather, uneven terrain, and unexpected events. Quadruped robots are often chosen for this type of task, as they're able to traverse over a wide variety of terrain, making them a popular choice for tasks such as inspection, monitoring, search and rescue, or goods delivery in difficult, unstructured environments. Now, usually predefined walking styles or gaits are applied to the robot that enables it to traverse such landscapes. However, the ORI team were interested in the development of on-the-fly gait adaptations that would make the robot better at dealing with unpredictable external influences. The ORI managed to present a robust and flexible approach for locomotion planning by utilising a deep generative model to capture features from locomotion data and enable detection and mitigation of disturbances. The model was able to show that for disturbances outside of those seen and learnt during the training phase, the Quadruped robot was able to reject a wide variety of impacts applied to the robot's base by increasing its cadence once detected. This rudimentary response is very similar to how humans increase their cadence to recover from slippage. Now, the last area that we'll look at is the use of radar odometry in automated driving. Odometry is the use of data from motion sensors to estimate the change in position of a vehicle over time, relevant to a specific starting location. Rapid and accurate data collection and processing is fundamental for odometry to be used effectively. So naturally, this places a large overhead on the systems required to collect and analyse the data in real time. Often these systems will be multi-GPU devices, so the study was to investigate whether the hardware could be scaled down without loss of performance. The ORI team used an odometry benchmark where for each 100-metre segment of up to 800-metre-long trajectories, it calculates the average residual translational and angular error for every test set sequence, normalising by the distance travelled. The performance across each segment and over all trajectories is then averaged to give the primary measure of success. Considering a like-for-like comparison at each resolution, ORI achieved speed-ups of 372% to 800% on an Intel Core i7 laptop and 424% to 470% on an embedded NVIDIA Jetson system. In summary, training faster and with less memory offered significant runtime performance improvements on a CPU and to run in real time on embedded devices. Throughout, the ORI approach remained accurate and competitive with the best radar odometry variants available to date. We hope you found this video interesting in understanding how AI can be developed to aid robotic advancement. This video is intended as a summary only, so we have put links to the more in-depth case studies from the uses that we've looked at today below for you. Do let us know your thoughts on this video and the case studies in the comments below, and we'll see you next time for a look at how AI is being employed in another sector.